All right, we are live. I do believe we are live. This is the Disciples of Yahweh. This is Truth Seekers, and come on in, pull up a chair. We don't have coffee tonight, unfortunately, but we're gonna have a great show tonight. And here to get us started is Brother Jodie.
All right, thank you, Brother Scott. We are the Disciples of Yahweh, YHWH in Christ. So just look us up on YouTube and subscribe, and also like and also share. This is a especially great program for all of our atheist friends. I know it has to touch a nerve because when I posted it on the Atheist Christian channel, I got a lot of hits and I've got a lot of comments. So praise God for that. So the atheists do care about this subject, and I think Christians ought to care about this subject. But subscribe to our channel, pray for us most of all, and pray that we can get these videos out. Share them with your atheist Christian friends. This is going to teach you a little bit more about what Christians need to know to know. And here to introduce our speaker is Brother Scott.
Thank you. I just want to say a word about these science videos just before I introduce our guest. This is not the first science video that we've done, and we do have a commitment to science, and Christians, I think, have dropped the ball on this issue. I will talk about this more in the question and answer and discussion period, but we need to take science back. There's nothing wrong with science. It doesn't contradict the Bible. Only the conclusions of secular scientists do. And it's been far too long that Christians have not been involved in science and have considered themselves enemies of science. All right, we'll talk about that more later. But right now, I want to introduce our guest. It's Rana from Reasons to Believe. Fuz is the vice president of research and apologetics over there. And Reasons to Believe is dedicated to communicating the powerful scientific support for Christianity. Among the books that he's published, Humans 2.0, Thinking About Evolution, and Fit for a Purpose. And tonight we're going to be talking about what Darwin didn't know. And so take it away, Fuz.
Okay, well, good evening, everybody. And Jodie and Scott, thank you so much for your hospitality and for having me on the show. Let me go ahead and share my screen, and we'll get this show on the road. Unfortunately, there's just no elegant way and smooth way to transition on Zoom. At least I haven't been able to figure it out when it comes to pulling up your slideshow. So anyway, what I was asked to address this evening is the question, or the topic really, what Darwin didn't know. And so that's what I'm going to do. I'll spend hopefully about 45 minutes, and then we're going to have plenty of time for Q&A and discussion. And, I want to start by I think, taking a moment to commemorate the fact that in a couple of days, we're going to be remembering the 9/11 terrorist attacks. And it was 20 years ago to, that 9/11 took place. And I can remember quite vividly, the just images of those attacks that I saw on TV. They'll be forever impressed in my mind. And then, on top of that, I remember just the chaos that surrounded that event in the days, the weeks, and even the months to follow, where there was very real concern about subsequent terrorist attacks and a recognition that we were extremely vulnerable as a nation. And during that time, Donald Rumsfeld, who was I think the Secretary of Defense, made this statement at a press conference. There are things we know that we know, and there are known unknowns. That is to say, there are things that we now know we don't know. But there are also unknown unknowns. There are things we do not know we do not know. And that's absolutely profound, because I think many of us who've lived life long enough realize that it's not the things that you know that is the problem. It's the things that you don't know that you don't know. And that really helps to formulate the theme for what we want to talk about this evening. Because when Darwin formulated his theory of biological evolution, there were some things that Darwin knew about biology, but there were a lot of things that he didn't know. And there were many things that he didn't know that he didn't know. And it's interesting because probably most of what we understand about, most of what we understand about biology today is what we've learned in the contravening 150, 160 years since Darwin published the book On the Origin of Species. And so it's fun for us to speculate, that if Darwin knew then what we know now about biology, would he have advanced his theory of evolution? Or if he did, would it look any different than it did when he proposed his ideas? And this question, what Darwin didn't know, was the title of an article that I wrote with Hugh in 2009 for Charisma magazine. And the reason why this article was published then was because in 2009, that was the 150th anniversary of Darwin's the publication of On the Origin of Species, and 200 years since the birth of Darwin. And so as a result of that, everything was about commemorating Darwin and his contribution to science. And that led to a booklet called What Darwin Didn't Know, that was really a reprint of that article that we published in Charisma magazine. And you can get a hold of this booklet. It's fairly easy to get a hold of. It's a bit dated now. If you really are interested in diving a little bit deeper into the questions relating to evolution and how to think about evolution from a Christian perspective, there's a book that I contributed to along with a team of authors called Thinking About Evolution that I would commend to you. Anyway, so let's go ahead and just spend a few minutes just sampling some of the things that Darwin didn't know about biology, and again, the impact of the insights that we've learned on the evolutionary paradigm. And I'm going to use that term evolutionary paradigm instead of the theory of evolution, because what I mean by that is that it's the notion or the idea that everything in biology could be explained exclusively through mechanism alone. And this would include the origin and the basic design of life. It would include the history of life and the diversity of life, including the origin of humanity. Now, one of the things when it comes to questions about origins is, how did life itself get started? How do we understand the origin of life in scientific terms? Now, in Darwin's day, there was a lot of speculation actually about the origin of life, but Darwin was very careful to sidestep the issue when he wrote On the Origin of Species. He didn't address the origin of life question. He just assumed that there were existing life forms, and from these existing primordial life forms, all life eventually evolved. But Darwin did, in a private correspondence to Joseph Hooker, offer an explanation for how life could have gotten started in evolutionary terms, where he wrote to Joseph Hooker, "The first spark of life may have taken place in a warm little pond with all sorts of ammonia and phosphoric salts, lights, heat, electricity, and so forth present, so that a protein compound was chemically formed, ready to undergo still more complex changes." And this idea has really served as the seed for modern day thinking about the origin of life in chemical evolutionary terms. And that idea of life coming out of a warm little pond was the inspiration for what is today known as the Oparin-Haldane hypothesis. And on the left is JBS Haldane, on the right, Alexander Oparin. Haldane was a British geneticist. Oparin was a Russian biochemist, and they independently produced a detailed explanation of how life could have emerged, starting with simple chemicals through a sequence of chemical pathways. And that idea today is known as the Oparin-Haldane hypothesis. And it is foundational really to, again, how scientists think about the origin of life question. And the textbook description of the origin of life is inspired by the Oparin-Haldane hypothesis. And I think many of us are familiar with it, where the idea here is that the early Earth's conditions were very different than the Earth today. And under these conditions, energy discharges like lightning through the atmosphere, or high energy radiation impinging on the Earth, or volcanic eruptions could have driven the formation of small organic materials that would have accumulated in the Earth's oceans or some other locale on the Earth, and that there would then be reactions that would take place that would complexify these prebiotic materials. There would also be a process of aggregation and self-organization that would eventually lead to the emergence of protocells that then would over time evolve into the first true life forms that would continue this evolutionary transformation until the last universal common ancestor was arrived at. And this is the organism or collection of organisms that would root the evolutionary tree of life. So this is the idea today, in at least in conceptual terms, for how life could emerge through chemical evolution, where again we see this chemical evolutionary process giving way to LUCA, and then LUCA being the anchor for the evolutionary tree of life. Now, the first validation for the Oparin-Haldane hypothesis is the well-known Miller-Urey experiment. And if you don't know what the experiment by name, I'm sure you are familiar with the experiment based on your courses in high school or college biology, because this is the experiment that was done in the 1950s by a graduate student named Stanley Miller, working for a Nobel laureate named Harold Urey. And this was all done at the University of Chicago, where Miller attempted to simulate the conditions of the early Earth's atmosphere using this experimental apparatus, where he had a flask of boiling water that would simulate the Earth's oceans, that sent water vapor into the headspace. He also had ammonia and methane and hydrogen in the headspace, was very careful to evacuate oxygen from the system. And then he sent electrical discharges through the headspace, and that led to the production of amino acids in very short order. And this was considered to be the very first experimental validation of the Oparin-Haldane hypothesis, but also was considered to be the inauguration of origin of life research as a formal scientific discipline. And so this is, again, a very important experiment scientifically and historically speaking. A number of years later, however, and this is something that I don't know is necessarily common knowledge, but a number of years later, origin of life researchers recognized that the conditions that Miller used in his experiment to simulate the conditions of the early Earth are not the conditions that actually are now believed to have existed on the early Earth. Instead of the atmosphere being made up of ammonia, methane, hydrogen, and water, we now know that the atmosphere consisted of water, carbon dioxide, and nitrogen gas. And in that particular mixture, electrical discharges or high energy discharges will not produce any kinds of organic compounds whatsoever. And because of that reason, many people now believe that the Miller-Urey experiment, though historically significant, is no longer truly relevant to the origin of life question. And what we see here is this idea that the conditions that were used by Miller in the laboratory, again, really don't adequately reflect the conditions that would have existed on the early Earth. And that really is the Achilles heel to this experiment. Since the early 1950s, however, original life researchers have gone into the lab and have replicated the Miller-Urey experiment, at least have been inspired by that experiment, looking for ways to simulate, again, different the conditions of the early Earth, different processes that may have taken place on the early Earth, and then have tried to, again, through that work, begin to gain insider understanding into chemical evolution. And original life researchers over the last 70 years have actually enjoyed some relatively significant success at identifying chemical processes and physical processes that could contribute to chemical evolution. They've identified pathways that could conceivably make most of the building block materials for life. They have been able to produce most of the biopolymers you would need for living systems. They can evolve RNA in the laboratory into a wide range of functional molecules, can generate self-replicating protocellular systems, and the list goes on and on. And, you know, we often hear that nobody knows how life could have originated. Nobody understands how chemical evolution could have produced the very first life forms. And that's a true statement. Most original life researchers would heartily agree with that. But they would argue that even though we don't know how chemical evolution could have transpired, we do believe that life still would have evolved. And the reason why is because we see these experiments in the laboratory where we have these clues for what may have actually happened. And so they look at this success as actually giving validation to chemical evolution. But I would actually argue that this sense of success is really a false success. And the reason why it becomes evident when we think about what you need to accomplish when you're doing laboratory simulation studies that are designed to recapitulate the different steps in the original life process. And what has been done up to this point successfully is to demonstrate proof of principle. In other words, original life researchers have identified in principle chemical and physical processes that could conceivably contribute to chemical evolution. They have figured out the chemical and physical mechanisms that undergird these processes. But what they have failed to do is show that what they've done in the lab actually has relevance to the conditions of the early Earth. This was, again, the problem with the Miller-Urey experiment. It wasn't the experiment itself, but it was rather that the experiment has no relevancy to the conditions of the early Earth. And this is actually a problem that plagues all of work in prebiotic chemistry. Because in order to be able to demonstrate, again, geochemical plausibility, you need to be able to show that what you're doing in the laboratory reflects the composition of the early Earth's environment, not only the materials, but the materials at the appropriate concentrations. You have to have energy sources that would be readily available on the early Earth. You have to show that the products that you produce in these reactions would have sufficient chemical stability to affect subsequent steps. You have to take into account chemical interference. And above all, you have to limit researcher involvement in these experiments. In other words, you can't have unwarranted researcher involvement. And this is really probably the most significant problem, is that when you are running these experiments, of course, by definition, you have to have researchers running these reactions, but you can cross a boundary or cross a line where suddenly the researcher has become involved to such a degree that they are actually affecting the outcome of the experiment. They are actually contributing to the experiment unwittingly in many instances. And so, of course, again, researcher involvement is crucial, but where does it become illegitimate? And it's not necessarily always that clear where that boundary lies. So in other words, it's one thing for researchers to go in the lab and to jimmy rig an experiment where you have the just right materials at the just right concentrations in the just right solvent with the just right pH and temperature. You're adding things at the just right sequence to generate successful chemical reactions, and you stop that process before those materials react further to subsequent products. It's one thing to do that in the lab, but that kind of control isn't available under the conditions of the early Earth. Organic chemists are present in the lab, but they're not present on the early Earth. And just to illustrate this problem, I want to talk about something known as the RNA world hypothesis. And this is a leading explanation for how chemical evolution could transpire, where the idea is that the very first cells had a biochemistry that was based exclusively on RNA, and that later the RNA world evolved to give rise to the DNA protein world. And one of the experiments that's designed, that is cited, I should say, to support the RNA world hypothesis is the assembly of RNA molecules on clay surfaces from RNA building blocks. And the idea would be that there would be clay and other minerals that would be available on the early Earth, and these could serve as sites where organic materials could accumulate, and the clay would have catalytic surfaces that could drive biopolymerization. And so many people have argued that this could be a way in which, again, the RNA world could get kick-started from RNA building blocks. And again, the fact that you can do these experiments in the lab suggests that this, again, is a viable mechanism. The problem is that when you examine these experiments in detail, it becomes evident that the researchers exclude materials that would have been present on the early Earth, but they exclude them from their experimental design so that those materials could not interfere with the production of the polymer. There's other materials that would have been present on the early Earth that would have hydrolyzed the polymer as soon as it formed. These are also excluded from the experimental design. They also stop the growth of the RNA chains before they became too long, because if they became too long, they would become irreversibly attached to the clay surface. And if that happened on the early Earth, it would shut down or frustrate subsequent steps in chemical evolution. But interestingly enough, in order to get the experiments to work, the researchers had to use chemically modified building block materials that were modified in such a way to make them more reactive. They had to get clay from a special supplier, treat the clay in a special way in order for the clay to function as a catalyst. As Paul Davies has said, as far as biochemists can see, it's a long and difficult road to produce efficient RNA replicators from scratch. This conclusion has to be that without a trained organic chemist on hand to supervise, nature would be struggling to make RNA from dilute soup under any plausible prebiotic conditions. Or Simon Conway Morris goes one step further when he says, many of the experiments designed to explain one or other step in the origin of life are either of tenuous relevance to any believable prebiotic setting or involve an experimental rig in which the hand of the researcher becomes, for all intents and purposes, the hand of God. So in other words, the irony here is that the very experiments designed to justify or validate chemical evolution and Darwin's ultimate idea of life coming out of a warm little pond have ironically provided us with evidence that apart from the work of intelligent agents, chemicals are not going to self-organize into protocells or into true cellular life forms, as simple as they may be. In other words, what the work in prebiotic chemistry has demonstrated is intelligent agency is needed for the origin of life. And the question, of course, is if Darwin knew this, what impact would this have on the nature of his theory and ultimately the evolutionary paradigm? Now, in Darwin's day, when it came to life in its most fundamental form, of course, at that time, cell theory was prominent. Everybody understood that life was composed of cells. as the fundamental unit of life, but Darwin held to what's known as the protoplasmic view of the cell, which viewed the cell as a very simple entity. And we now know, of course, that this is not the case, that the cell is now understood to be an incredibly complex chemical environment. But it's not just simply the complexity of the cell that actually, I think, raises questions about the idea of life emerging again out of a warm little pond, but rather it's the fact that that complexity takes on a particular character. It has certain properties or attributes to it that suggest the work of a mind. Biochemical systems are incredibly complex, elegant systems that are sophisticated, that display an ingenuity. But as we've studied these systems now, thanks to all kinds of advances in our ability to probe life at its most basic level, we've discovered that many of the hallmark features of biochemical systems are identical to the hallmark features of systems designed by human beings. In other words, when we as human beings design or invent or create something, whether it's a system or an object or a device, those things we make have certain telltale properties that indicate to us that these are indeed the work of a creator, of an agent, of a personality, of a mind, if you will. And the fact that we see these same attributes defining biochemistry suggests that life itself must too come from the work of a mind. In addition to that, there are many biochemical systems that actually are direct analogs to human designs. And I'm going to talk about one of them today, and these are what are known as molecular machines or biomolecular machines. And the molecular machine that I want to focus attention on is something known as F1, F0 ATPase. And this is a diagram showing F1, F0 ATPase in two different representations. One is on the left called a ribbon diagram, and on the right, it's called a space-filling model. Now, before we get into this, I want to give us just a little bit of an orientation so you can fully appreciate what it is that you're looking at when we talk about this particular molecular machine. This is a cartoon showing a cutaway of a typical animal cell. And you see all kinds of internal organelles and structures. But what I want us to focus on is the cell membrane, which is a very thin, almost nondescript envelope that separates the interior of the cell from the exterior environment. And at this level, it doesn't look like, again, there's very much complexity to the cell membrane. But if we blow up a small segment of the cell membrane and look at it in what's called a supramolecular diagram, which is something that biochemists use to get a sense for how different molecules associate with each other. So you're looking at overall shapes of molecules and then how those molecules interact together. You see that the membrane is a very complex system made up of a huge number of molecules. Many of the molecules are relatively small molecules that form a sheet that consists of two layers. This is called a bilayer. And embedded in that sheet are these larger structures. These are called proteins. And it turns out that the proteins are the molecules that give the membranes their functional properties, their functional attributes. And the proteins themselves are very large molecules that are formed by linking together smaller molecules called amino acids into a head to tail manner. And these amino acids form chains that can then fold and adopt a variety of different three-dimensional conformations that in turn can interact with other protein chains to form a complex. And so when we look at, like that pink globular structure there, that's kind of an overall shape, but it's composed of probably multiple protein chains that are folded and packed together to form that overall shape. And so when we look at F1, F0 ATPase, this is a protein complex that has a very interesting molecular architecture. It is essentially a molecular rotary motor that is electrically powered. And we can see here that in the membrane is embedded a cylindrical structure. This is called the F0 part of the molecule. There is a rod-like structure that extends out of this. This is the rotor, the cylindrical structure embedded in the membrane is the motor. There's a cam at a right angle, and as protons, which are positively charged, flow through channels in the F0 component, that flow is essentially an electrical current that energizes the movement of the rotor. And as it rotates, the cam will interact with these green and blue ovals. These are called turbines that undergo a mechanical displacement that drives a chemical reaction that produces a molecule that could be used, that's used by the cell for energy purposes. It's like the gasoline of the cell, if you will. And here is a video showing the F1, F0 ATPase in action. But look at the machine-like properties of this particular protein complex. And so what we see here is, again, the complexity is astounding. And, you know, we know from experience that to build a motor, to build a machine requires, again, intelligent agency. And when we see that many of the biochemical systems inside the cell are literally operating like machines, this again is eerie and suggests the work of a mind. In addition to molecular machines, we also have some biochemical systems that are information storage systems, information harboring systems. One of them is the DNA molecule. In fact, within DNA is essentially digital information. And that digital information is analogous to the digital information that we would manipulate in computer systems. But recently, biochemists have come to realize that the cell's machinery that manipulates DNA during processes like DNA replication or DNA repair or transcription are literally operating like computer systems at their most basic fundamental level. And to appreciate this, we need to think for a few minutes about the work of British mathematician Alan Turing. In the 1930s, Alan Turing did theoretical work that laid the foundation for modern day computer science. And what he did is he developed a hypothetical machine called a Turing machine that would essentially form the basis for constructing computer systems. And this machine consisted of an input, an output, and a finite control. And this is how, this is a cartoon imagining what a Turing machine would look like, where you'd have essentially digital information being fed into something called a finite control that could alter that digital information in a prescribed manner to produce an output, a digital output. And Turing's genius was to realize that the output of one machine could become the input of another. And by combining Turing machines together, you could perform very complex operations. And this, in effect, is what happens during DNA replication, where the DNA double helix, which harbors the digital information, is in effect the input. And there are a score of these proteins that manipulate DNA during the process of DNA replication, altering the DNA input ever so slightly, producing an output that in turn is operated on by other proteins that then in turn produce outputs. And by combining all of these operations together, you can perform a very complex computation, namely DNA replication, where again, the DNA is the input and the output, and the proteins that manipulate it are the finite controls. Here's a video showing the process of DNA replication. And again, think about this now in terms of Turing machines as we look at this video. So the point here is that what we're seeing here is, again, in effect, a computer operation that is undergirding one of the most critical processes in all of biology, namely DNA replication, where again, DNA is the input and the output, and the proteins that manipulate it are the finite controls. In fact, the similarity between DNA replication and how a computer system operates is so stark that it has inspired a new area of nanotechnology called DNA computing. This is Leonard Adleman, the father of DNA computing, and this is what he writes. The most important thing about DNA computing is that it shows DNA molecules can do what we normally think only computers can do. This implies that computer science and biology are closely related, that every living thing can be thought to be computing something, and that sometimes we understand living things better by looking at them as computers. And these DNA computers that are being built are more powerful than silicon-based computer systems. And they're wet computers that are housed in little tiny Eppendorf test tubes that are about this big. But again, and they're made up solely of DNA and proteins, and yet they are able to carry out these complex computations, solving problems that standard silicon-based computers can't solve. But both examples bring to mind, if you're familiar with this classical design argument, but bring to mind the watchmaker argument advanced by William Paley. And in the late 1700s, William Paley published a book called Natural Theology, where he argued in this work that a creator must be responsible for life through analogical reasoning, where Paley pointed out that a watch, which in his day was the pinnacle of engineering achievement, that a watch is distinct from something like a rock, which can be readily explained through the outworkings of natural processes. For Paley, he was arguing that a watch clearly is the work of a watchmaker, and it has certain attributes that suggest the work of a mind. And that when he surveyed biological systems, these biological systems had more in common with a watch than a rock. And so he argued that if a watch requires a watchmaker, life must require a creator. Now, the watchmaker argument hasn't fared very well over the years, and one of the challenges to the watchmaker argument is essentially the mechanism of natural selection, where Darwin's theory of evolution argued that natural selection could explain even the design that we see in biological systems. That the design that we think we see is really not true design, but an artifact of the outworkings of natural selection. And in fact, Origin of Species was written in effect as a rebuttal to Paley's natural theology. Darwin had Paley over on his shoulder as he was writing his book on the origin of species, where it is really one long rebuttal to natural theology. And so people would argue that Darwin's mechanism has unraveled the watchmaker argument, but I would actually argue that that's not the case whatsoever. I would argue that what we see with advances in biochemistry are in effect revitalizing the watchmaker argument, and the challenges that we're seeing that come from work in prebiotic chemistry and the problem of unwarranted researcher involvement really undermines this idea that natural selection could explain the fundamental design of life. And so I think the elegant design of the cell represents, to me, one of the most significant challenges to the evolutionary paradigm. I'm not sure how I'm doing here on time. I need to speed things up here, I think.
You're good. Take as much time as you need to do a
okay.
fine job.
Okay. All right, so next thing I want to talk about is the fossil record. In Darwin's day, the fossil record really didn't support his theory. In fact, in his book, he has a chapter devoted to problems with his theory. So Darwin was a fair-minded scientist, and he acknowledged observations that seemed to challenge his theory. One of them was, again, features in the fossil record. And there's a number of different features that troubled Darwin. One of them was something known as the Cambrian event, or the Cambrian explosion. And this is how Darwin describes the Cambrian explosion. There's another and allied difficulty, which is much more serious. I allude to the manner in which species belonging to several of the main divisions of the animal kingdom suddenly appear in the lowest known fossiliferous rocks. To the question why we do not find rich fossiliferous deposits belonging to these assumed earliest periods prior to the Cambrian system, I can give no satisfactory answer. What Darwin argued, though, in his book is that in his day, geology and paleontology were really disciplines in their infancy, and Darwin was convinced that as we began to study the fossil record and the paleontological record, that the mystery associated with the Cambrian explosion would essentially evaporate. But it hasn't. In the contravening 160 years, we now know that the Cambrian explosion is a real event in life's history, when in a geological instant, somewhere between 50 to 80% of the animal phyla that have ever existed show up explosively in a narrow window of time. And currently, there is really no good evolutionary explanation for the origin of the Cambrian explosion. In fact, people like Doug Irwin and Jim Valentine, in their textbook on the Cambrian explosion, basically argue that current evolutionary theory simply cannot explain, again, the Cambrian explosion. One important concern has been whether the microevolutionary patterns commonly studied in modern organisms by evolutionary biologists are sufficient to understand and explain the events of the Cambrian, or whether evolutionary theory needs to be expanded to include a more diverse set of macroevolutionary processes. We strongly hold to the latter position. The move from micro to macro forms a discontinuity. And of course, when you look at the Cambrian explosion, this is, to me, a signature for creation. What would it look like if a creator intervened to bring about the sudden appearance of animal life on the earth? Wouldn't it look like out of nowhere these animal forms appear in the fossil record? Richard Dawkins says the Cambrian strata of rocks vintage about 600 million years are the oldest ones, which we find most of the major invertebrate groups, and we find many of them already in an advanced state of evolution the very first time they appear. It's as though they were just planted there without any evolutionary history. So in other words, the question is if Darwin realized that the Cambrian explosion was indeed a real event in life's history, not an artifact of the fossil record, would he have advanced his theory of evolution, or at least argued that his theory had this ability to account for the totality of life's history? Something else that Darwin identified as a challenge to his theory were organs of extreme perfection. And the eye, the vertebrate eye, was the focus of Darwin's concern. And the reason why Darwin focused on the eye was because in his book, Natural Theology, William Paley highlighted the eye as an example of an organ of extreme perfection, where Paley argued, given the complexity and the sophistication of the vertebrate eye, he argued if that was the only biological feature we examined, on that basis alone, we would be justified in concluding that a creator was responsible for life. And so Darwin argued that even that natural selection could even explain something as complex as the eye, where he said if numerous gradations from a perfect and complex eye, from a perfect and complex eye to very imperfect and simple, each grade being useful to its possessor, can be shown to exist. If further, the eye does ever so slightly, and the variations be inherited, which is certainly the case, and if any variation or modification in the organ be ever useful to an animal under changing conditions of life, then the difficulty of believing that a perfect and complex organ can be formed by natural selection, though insuperable to our imagination, can hardly be considered real. In other words, Darwin argued, give enough time and that the eye could evolve, and that it could start from a simple eye spot and over time become increasingly advanced and sophisticated till over time the vertebrate eye emerges. And Darwin and other evolutionary biologists will point to different degrees of complexity in visual systems in different animals as essentially examples of potential intermediate forms that could lead from an eye spot to the emergence of complex vertebrate eyes. The problem here is, and so this is kind of a diagram showing the evolution of the camera eye. The problem with this is that when we survey the different phyla and we keep in mind their proposed evolutionary relationships among the different phyla, what we actually see is that eyes have evolved independently multiple times in life's history. And so what we're asked to believe is that these complex visual systems didn't emerge a single time, but emerged, again, independently multiple times, and that instead of these different forms showing up sequentially, where the simplest forms appear originally and more complex forms of the eye appear later, they all show up simultaneously. They all coexist in the fossil record, and they all are represented in the Cambrian explosion. We see in the Cambrian explosion evidence for the compound eyes of arthropods, and we also see some indication of even the vertebrate eye in the fossil record represented by the Cambrian. So in other words, we don't see this gradual evolutionary emergence of the eye, but the eye shows up suddenly in all its different forms in the Cambrian explosion. And again, if Darwin knew this, would he have argued that organs of extreme perfection don't pose problems for natural selection? Okay, one final topic, and then we'll turn the floor over to you to offer your thoughts and to ask questions. Let's take a look at the question of human origins. Now, in the Origin of Species, Darwin, again, was very careful not to discuss the origin of humanity. But later on, not a little more than a decade later, in a book called The Descent of Man, he basically argued that human beings have an evolutionary origin as well. In The Descent of Man, he writes these words, these now famous words, where he says, in a series of forms graduating insensibly from some ape-like creature to man as he now exists, it would be impossible to fix on any definite point when the term man ought to be used. And this idea that human beings only differ in degree, not kind, from other creatures has really shaped evolutionary anthropology over the last 150 years, where people argue that everything that we think to be special about human beings is the outworking of evolutionary processes, and that are those attributes that we think make us unique, make us exceptional, make us special as human beings, actually have their antecedents in the hominins that precede us in the fossil record. But what's interesting is, in recent years, there's a growing number of anthropologists and primatologists who argue that human beings actually are different in kind, not different in degree from other creatures, and that there's a chasm that exists between our cognitive capacities and that of even our closest closest quote unquote evolutionary ancestors or relatives. And that unlike Darwin's proposal, that we really are different in kind, not different in degree from other people. And one of those scientists is Thomas Suddendorf, who makes this case in his book called The Gap, where he writes, "We reflect on and argue about our present situation, our history, and our destiny. We envision wonderful, harmonious worlds as easily as we do dreadful tyrannies. Our powers are used for good as they are for bad, and we incessantly debate which is which. Our minds have spawned civilizations and technologies that have changed the face of the earth, while our closest living animal relatives sit unobtrusively in their remaining forest. There appears to be a tremendous gap between human and animal minds." And it turns out that what makes us exceptional is a combination of four attributes. As human beings, we uniquely have the ability to represent the world with symbols, that we have open-ended generative capacity, meaning that we can manipulate those symbols in an infinite or near infinite number of ways. That we have theory of mind, where we realize that others have minds like ours, and that we can anticipate what others are thinking and feeling, and that we have a desire to link our minds together. And we do this through very complex social hierarchical systems. And so, in other words, as human beings, we stand apart from all other extant creatures in these suite of capacities. Now, there are some people that argue that human beings indeed are again unique and exceptional compared to existing primates, but that hominins like Neanderthals also had capacity for symbolism as well, and that we really are not any different than the Neanderthals. And there's claims that Neanderthals made art and jewelry and music and possessed language and buried their dead and mastered fire. But as it turns out, every claim about Neanderthal exceptionalism doesn't withstand ongoing scrutiny. All those claims, though they appear in the scientific literature, have been overturned by subsequent studies. And to me, the ultimate piece of evidence challenging the symbolism in Neanderthals is the fact that Neanderthal technology is static. Neanderthals were on Earth longer than humans have been on Earth, and their technology remained static before it went extinct. It didn't really evolve. There was no cultural evolution, whereas humans appear and our technology is initially primitive, but within a relatively short period of time, our technology has grown to the point that we are now able to put people on the moon. Noam Chomsky, Ian Tattersall, and other collaborators write, our species was born in a technologically archaic context. And significantly, the tempo of change only began picking up after a point at which symbolic objects appeared. Evidently, a new capacity for symbolism or for symbolic thought was born with our anatomically distinct species, but it was only expressed after a necessary cultural stimulus had exerted itself. That stimulus is most plausibly the appearance of language. Then within a remarkably short space of time, art was invented, cities were born, and people had reached the moon. And just to illustrate this, let's take a moment and look at the origin of language, because our capacity for symbolism is most clearly manifested in our ability for language. That seems to be the trigger. And from an evolutionary perspective, the view would be that language would have evolved progressively over time, where maybe Neanderthals had some kind of primitive language that then gave rise to a more simple language, and then complex language later emerged. But instead of seeing this pattern of evolution, we see something very different when it comes to the origin of language. namely that language appears suddenly out of nowhere, coincidentally with the emergence of modern humans. And as evolutionary biologists try to explain the origin of language, they are stymied. Chris Knight says this: language evolved in no other species than humans, suggesting a deep-going obstacle to its evolution. One possibility is that language cannot evolve in a Darwinian world, that is, in a world based ultimately on competition and conflict. The underlying problem is that the commutative use of language presupposes anomalously high levels of mutual cooperation and trust, levels beyond anything which current Darwinian theory can explain, suggesting a deep-going obstacle to its evolution. And again, the mode and the tempo for the origin of language is not what you'd expect in evolutionary terms. It appears suddenly, coinciding with the origin of modern humans, and it's unique to modern humans. And the first language seems to be as syntactically complex as modern day languages. Miyagawa at MIT says hierarchical complexity found in present day language is likely to have been present in human language since its emergence. Chomsky and Tattersall say this: by this reckoning, the language faculty is an extremely recent acquisition in our lineage and is acquired not in the context of slow, gradual modification of pre-existing systems under natural selection, but in a single rapid emergent event that built upon those prior systems, but was not predicted by them. This relatively sudden origin of language poses difficulties that may be called Darwin's problem. And to me, again, the origin of language is a manifestation, or a capacity for language is a manifestation of the image of God. And those scientific properties that make us unique compared to all other creatures, including Neanderthals, could be understood as scientific descriptors of the image of God. So the point here is that that if Darwin knew then what we know now, would he have truly advanced his theory of evolution? I think he probably would have still advanced his theory of special evolution, which was to explain the origin of species by natural selection. And he might have even argued that over time, this mechanism could maybe even explain the origin of families, or the origin of genera, the origin of families. But I don't know that he would have necessarily so boldly argued that this mechanism could explain the totality of biology, including ultimately the origin of life and the origin of humanity. I think his ideas would have been much more limited in scope. And here we are 150 years later, and we see that by looking at what Darwin thought to be, in many instances, some significant problems with this theory, that these problems are still persisting today. And in light of that, I think skepticism about at least aspects or facets of the evolutionary paradigm is indeed a legitimate posture to take. And I'll go ahead and stop there and let you guys now get involved in the conversation.
Wow, I'm loving this. I love how much breadth you covered there, even going up to language, from microbiology up to language. Friends, if you're just joining us, we have Dr. Rana from Reasons to Believe, and I want to welcome all of you who are in the YouTube chat. If you have a question, go ahead and type it in. If you want to join us on the live stream, the link is in the chat box if you want to join us on Zoom, to ask a question live. If you type in a question, I'll read it out. But Fuzz, something that you said there at the end when you were talking about language made me see an interesting tie back to microbiology that you were talking about earlier, because what we find in the DNA molecule and the systems that encode and decode and write, all this is language words that, the letters of the DNA ATGC, they form words, and those words have meaning, and there are messages that are encoded on strands of RNA that are sent somewhere, and then they're decoded or read back. And all of this is like language processing, that the things that are read have a meaning and tell the information systems and the technology in us to build something. So we find language was already inside of our biology before we invented language, or as you were saying, language emerged among humans. So I thought this is a wonderful time back.
Yeah. Well, Scott, let me just offer a couple of quick comments. First of all, you made the point that I covered quite a bit of ground from the origin of life and biochemistry to the origin of language. And part of the reason I did that is because it's the nature of the evolutionary paradigm. It's really presented as this explanation for the totality of biology. Mm-hmm. And so that's in a sense why I touched on so many different areas. It's important to note that, yes, indeed, there are evidences that people can point to that again seem to support an evolutionary view of life, but there's also some very significant challenges that I think at least legitimize some measure of skepticism about the overarching explanatory power of evolutionary theory. But to your point now about language, that's a very insightful comment, Scott, by the way. I love your insight there. And it's interesting, I didn't get into this, but there are information theorists who work on problems in molecular biology. And many of them have noted that there is a correlation between the structure of human language and the structure of information in biological systems, in biochemical systems. So in other words, it's not just simply the presence of language, but that language actually takes on a form that is highly reminiscent of human language. In fact, a few years ago now, a team of biophysicists actually showed that there is a biochemical grammar that exists, rules for how that information interacts with and that the structure, the mathematical structure of that grammar was again highly reminiscent of the mathematical structure of human language and the grammar associated with human language. So it goes beyond just simply the presence of language, but it's the fine structure of that language in biochemistry is reminiscent of human language. And of course, if you think about there being a creator, a single creator that brought everything into existence, it would make sense that you would see that kind of uniformity, in the deep structure of life, right? That design, and yet that uniformity to that design would permeate everything.
Yeah, and it brings up another thing that you touched on, which was the watchmaker argument. I love how you brought that back and are not afraid to touch it. I think a lot of people are like, oh no, let's not use that anymore. But I actually think not only should we embrace the watchmaker, we need to update it. And this brings up something that happened in the chat. Rob said this, he said, so we have organic machines running in us, and with a question mark. I don't know if that was a statement of incredulity or just a question. And I wrote back and I said, yes, these molecular machines that we have inside of us are like the nanites that you see in Star Trek. So in science fiction, they've proposed these tiny little molecular machines that can do computing, they can act in swarms, and they're capable of doing all kinds of operations at a molecular level, and even thinking. And this is the kind of technology that we find inside of ourselves. You were saying Paley was using the watch because it was the pinnacle of scientific achievement at that time. But we have speculative, technological thinking about what the future could hold, that we could maybe produce these nanites. Well, when we look inside of ourselves, we find this future technologies already existing in us. And it's something that we can't even produce. And it's so sophisticated that people are copying it. Since we get the technology of biomimetics and this DNA computing that you mentioned. I hadn't heard of that, by the way. Thank you for sharing. DNA computing is also a form of biomimetics. The guy is saying, look what this technology can do at a microscopic level. Let's reproduce it. So all of this points back to the creator. All this information, all this technology in us, it says it requires an extraterrestrial intelligence. If it's not God, then you have to go with panspermia, but then you need something to explain the panspermia, and you just set things back. So I love how all of these things just point to God. That's my point.
Yeah. Well, I really love the watchmaker argument. And, ultimately, everybody who has attempted to try to come up with a criteria to detect design, in biochemical systems, whether it's Behe's irreducible complexity, Dembski's specified complexity. If you're familiar with Doug Axe, his book Undeniable, he has, I think, a concept called functional coherence. Marcos Eblin has this concept of foresight. And in my book, The Cell's Design, I suggest a kind of an intelligent design pattern, right? Which is all of those ideas ultimately are connected to Paley's thinking in the watchmaker argument, where he says there are just these attributes that we intuitively see and recognize as the work of a mind. And he called them contrivances. So we really owe a huge debt to Paley. And I know that people like to distance themselves from the watchmaker argument because everybody argues, well, Darwin showed natural selection is the watchmaker. And, Hume pointed out all the logical problems with it. But I've actually written in my book, The Cell's Design, it's essentially a revitalized watchmaker argument in that book. But I also, on my blog, The Cell's Design, named The Cell's Design, over the years, I have responded to logical critiques that are presented today to watchmaker thinking, one by one, showing that none of the logical arguments really are valid, or logical challenges against the watchmaker argument are valid, and have even, addressed, I think that the way to address the natural selection as the blind watchmaker in biochemistry is looking at the origin of life problem, because that's the evolutionary process that would explain biochemistry. So I think we've handled the objections to the watchmaker argument, and it's just stronger than today. And in fact, in the book, The Cell's Design, I propose something called the watchmaker prediction, which basically argues that if indeed the watchmaker argument is valid, that what's going to happen is that as we invent new technologies, particularly at the nanoscale, that we're going to discover that there's already representations of that technology in the cell. We just didn't realize it until we invented the technology. And in more recent work, I actually update the watchmaker argument, showing that prediction that I made in the book is actually coming to bear. And then I also have developed what I call the converse watchmaker argument, which is, what Paley did is said, okay, we know how human designs look, and now let's apply that insight to biological systems and make an argument for God. Well, the converse watchmaker argument goes the other direction. If a creator is responsible for the designs we see in biochemistry and in biology in general, then these designs should be so elegant that they would inspire technology. And you were mentioning biomimetics. And so to me, that the discipline of biomimetics is essentially, or could be recast as the converse watchmaker argument. Again, this is not deductive reasoning, by the way, it's inductive reasoning. So we're not confirming the antecedent or whatever that is, but with the converse watchmaker argument. So anyway, I think Paley looms large, and it's sad to me that we don't more strongly embrace Paley. And when I think Paley is a underappreciated genius, actually. The more that I read Paley and the more that I think about the way he reasoned, the more I really appreciate the incredible insight he had into the design argument.
Did you say you answered these things on your blog? And where can we find that blog?
Yeah, Cells Design, the blog is at reasons.org. So if you go to reasons.org and you search blogs, there's the Cells Design, and you just kind of scroll through it and you'll see, over the last several years, I've addressed a number of the watchmaker challenges.
All right, thanks. Jodie, I want to check in with you, see what you have to say.
Yeah, I think even the cell argument is even better than the watchmaker argument, because the cell is a whole lot more advanced than even the watch. And I'm just wondering, all the facts, all the evidences, all the design arguments, do you have to be delusional to not believe in a creator? I mean, it seems like they're such flawed. I mean, even atheists admit that they seem to be a design, but they don't want to go over and say, yes, they're a creator. I mean, it just seems like they have to use other objections. And it seems like your book, The Cell Design, I mean, is even better than the watchmaker argument. I mean, the cell is so much more complex and so much more dynamic than even the watch is. So what about that?
Yeah, well, I mean, couldn't agree more. There's nothing to disagree with in what you said by any means. It's interesting to me that biologists cannot escape using design language. Mm-hmm. And everybody would agree that biological systems have the appearance of design. Biochemical systems have the appearance of design. But what's interesting, I think it was in the 1950s, and I don't remember the name of the philosopher of science that coined the term off the top of my head now, but coined this concept of teleonomy, which is essentially saying, well, there is design in biology and biochemistry, but that design is produced by natural selection. So teleonomy allows us to use design language, but we all understand that we really are not referring to teleological design, but design that's an outworking of natural processes. But this is just simply, to me, a maneuver to legitimize the use of design language in a context that is thoroughly anti-teleological. And really, you hear many times people talking about the Darwinian revolution. And what they mean by that is with Darwin's theory of evolution, what he did is what was probably the most outlandish idea that he had was that the design that we see in biology and the exquisite adaptation that organisms display for their environment is the product of natural selection. Because prior to that, biology was teleological, where people saw design and purpose in biological systems. And there was a debate whether it was function or form that was more important as the criteria or the organizing principle for that design. But everybody recognized that there was a mind that produced that design. And biology was the last bastion of teleological thinking. All the other disciplines were organized around mechanism, except for biology. And so what Darwin did with his theory of natural selection is he gave a mechanism to biologists. And so mechanism can now supplant mind. As a result of that, and because, again, of the long shadow that Paley casts, biology becomes staunchly anti-teleological. And so Jodie, to your point, there's a deep rooted commitment to materialism, and there is an absolute refusal to allow any type of teleological mechanism or teleological encroachment on biology. Biologists will resist that to absolutely no end. And so it really is almost a worldview issue, more so than anything else.
So how did you choose, or when you was younger, how did you actually choose the science that you enjoyed the most to actually go into it? And was you a creationist when you got in science, did you ever believe in evolution, or why did you choose the particular science that you're in?
Well, I was an agnostic when I started my undergraduate studies. I embraced the evolutionary paradigm. And it was as a graduate student studying biochemistry that I recognized, based on the design of the cell and the challenges associated with chemical evolution, that life itself must have come from a mind, that the very first cell and the fundamental structure of biochemistry must be the work of a mind. And that opened me up to really hearing and responding to the gospel for the first time. But even after coming to faith in Christ, I would have been a theistic evolutionist. I would have argued that the origin of life required the involvement of a creator. But after that point, the rest of life's history was through evolutionary means. And it was really about a decade later that I began to really question in a serious way aspects of the evolutionary paradigm. And so I went from being an agnostic who embraced the evolutionary framework to a Christian that was a theistic evolutionist, is now what I would call myself an old earth creationist. So that was kind of the trajectory of my journey. And, you know, it is interesting to me, though, I am beginning to see some expressions of evolutionary theory that actually are strongly teleological, and I think really begin to create a space where someone could be a theistic evolutionist, but also at the same time strongly embrace the idea of design, where this is an idea called structuralism, and I won't get into the details of it, but I'm beginning to see the emergence of another category where it would really be like a teleological evolution. And so this is very different than somebody saying, well, God just used evolution as a way to create. I mean, part of this idea of structuralism is, yeah, indeed, God did use evolution as a way to create, but they see evolution in strongly teleological terms, where there's a directionality to it, where there's a purpose, there's an intent behind the process. And that's radically different than how evolutionary biologists today conceive of evolution, which is unguided, lacking any kind of direction, any kind of purpose. And so it'll be interesting to see what happens with structuralism. I'm highly sympathetic and supportive of that work, and think that that creates a really interesting option for people. And it's not, again, your grandfather's version of evolution. And it's interesting because there's a lot of people that are evolutionary biologists that are deeply troubled by structuralism, by the way, because it's teleological.
Okay. Are you currently working on any books?
Yes, in November, we hope November, we're in this COVID time that we live in, we're having some trouble getting books printed, believe it or not. So the book is at the printer, and we're told November 1, but who knows? But it's a book called Fit for a Purpose, and it's essentially a new design argument that is essentially making the case that we see the anthropic principle manifested in the design of biochemical systems. And as far as I know, this would be the first book where somebody lays out a comprehensive case for the biochemical anthropic principle. And so the idea would be that biochemical systems are fine-tuned, that there's a molecular fine-tuning that we see, and that if biochemical systems were any different than they were, then life could not exist. Life has to be exactly the way that we see it, and that there's fundamental reasons why biochemical systems are the way they are. And these systems have the just right properties for life to be possible, and there's no alternatives. That's essentially the case I'm making. And so it's very similar to the fine-tuning argument you would see in cosmology.
All right. Do we have any questions on the YouTube channel?
No, not right now. I wanted to ask you something, Fuzz, about the trends in biology among the academics, because I heard about the Royal Society conference. I think it was back in 2016. New trends in evolutionary biology, where they were getting together to say, hey, there are problems with neo-Darwinism. What can we find to replace it, or how can we modify it, make it better? And I never heard any more sound or noise from that quarter. But as you say, there are some people who are taking a kind of third way or a middle road. In fact, I've heard them called a third way, in which is lumped a number of different ideas that people have. They're not necessarily God or creation models, but there are so there are these different camps. You've got the evolutionists on one side, you've got creationists and intelligent design on the other side, and then there's kind of this middle camp. Are you aware of these trends? Are there still problems and people talking about problems with neo-Darwinian evolution who are inside the academic echo chamber? Are there still questions and problems being discussed? That's what.
Yes. Well, I mean, you're making reference to something known as extended evolutionary theory. So there are a number of biologists who think that evolutionary theory is incomplete. It's not that it's wrong, but it's incomplete, and that if we're going to explain some of the most significant problems in evolutionary biology, like the origin of novelty, that's a huge problem. Or if we are going to try to understand the Cambrian explosion and the origin of body plans, that we need essentially to expand evolutionary theory beyond what it currently exists. In fact, the quote that I presented to you from Doug Irwin and Jim Valentine is a reflection of that thinking, that the microevolutionary mechanisms that are so successful to explain some features of biology don't seem to be able to account for the Cambrian explosion. There needs to be something done. There needs to be an extension. And so to me, this is essentially legitimizes some of the criticism coming from intelligent design and people and creationists who are pointing out these shortcomings, that evolutionary theory seems to fall short when it comes to accounting for, key transitions in life's history. And so I think, I don't know that I would say that it necessarily says the evolutionary paradigm is in deep trouble, but what it is saying is that currently evolutionary theory is incapable of explaining certain transitions. It doesn't have the resources to account for these key events in life's history. And I think that, again, is in and of itself significant. Now, it's important to note that there are many biologists who don't think the extended evolutionary synthesis is necessary. They think that current theory is sufficient. But again, this is reflecting cracks in the framework. There are evident cracks in chemical evolution, and origin of life researchers, to their credit, are forthright enough to acknowledge the fact that there are conceptual issues that they're confronted with in their discipline, and they're willing to acknowledge that. I don't think evolutionary biologists are at that point yet, but you can begin to see, some of these concerns beginning to percolate to the surface.
Yeah, I think they probably feel like there's no place to go. I mean, if they're not going to embrace creation, and they will have to abandon Darwinism, neo-Darwinism, because it doesn't work, they have no place to go. So they're trying to invent something.
Yeah. Well, this is where structuralism becomes very interesting, because, for example, when we talk about the origin of body plans, a structuralist would say, well, the body plans that we see, and there's about 30 or so phyla, so each phyla corresponds to a body plan. The structuralist would say that the body plans that we see in nature are essentially dictated fundamentally by constraints of the laws of physics. That is, these are the only body plans that could exist given the laws of physics. And the eerie thing is that these are precisely what you need to have, the incredible diversity of life that we see, right? They would even argue that embryological development is being driven more by constraints in the laws of physics than actually by anything else. Now, what this means is that it's not natural selection or a historically contingent evolutionary process in history that has produced life, but life is fundamentally prescribed by the very laws of nature, right? That's strongly teleological. Now, that it helps to solve the problem of how do you explain the origin of body plans? Because once you create multicellularity, body plans are going to emerge as a result of the laws of physics. So it's very intriguing, but it suggests that there's a directionality, that there's an intent that is undergirding the history of life. Now, you could probably hold that view and not be a theist, but if you are a theist, that structuralism is forcing you, or structuralism is forcing you into a regime that is thoroughly compatible with theism and the idea of a creator that's ultimately responsible for life, right? And so to me, the interesting thing is that whether you look at, biology and you acknowledge the cracks that are in the edifice, right, that are suggesting design, or you're looking at structuralism, you're being forced to the same place where somehow there is design in the system, whether that design is imposed through the direct intervention of a creator, or is that design fundamentally instantiated within the structure of the universe. Either way, you're in a design arena, right? Where I suspect it's probably a combination of both things. That's actually where I land in my book, Fit for a Purpose, is that it very well could be a combination of both that explains biochemistry.
Someone in the chat said, I thought Darwin was an atheist. Do you know anything about Darwin's faith?
Yes, Darwin was an atheist. Now, in his lifetime, he wasn't very forthright with his religious views, and he would many times write in pious language and in religious terms as he described his theory. And I think that was in retrospect, that was really a political maneuver on his part, where he didn't want his theory associated with atheism because that would undermine acceptance of the ideas. And so, he always was very, vague, and ambiguous about his religious affiliation. But he wrote an autobiography that was never intended to be published. It was really something that he wrote for his family to have after his death. And in the autobiography, he makes it very clear that he was an atheist. And he, interestingly enough, he started off as a Christian theist. In fact, he was his formal training is in theology. He was trained to be a clergyman and was self-taught as a naturalist. And it was really his experience, I think, on the Beagle, coupled with what we would call the problem of natural evil today, that really, I think, pushed him towards atheism. And really, I've heard some people argue that that the origin of species is actually a theological work, where it really is presenting a theodicy to the problem of evil, where, and if you look at some of the private correspondences that Darwin had, it's very clear he was troubled by the problem of natural evil. He struck up a friendship with a biologist by the name of Asa Gray, a botanist in the US. He was at Harvard University, a very well-known botanist. And Asa Gray was the first scientist in the US to embrace Darwin's theory. He also was a devout Presbyterian, and in his book, Darwiniana, which is a collection of essays where he's introducing the American public to Darwin's theory, he has a number of essays where he talks about evolutionary mechanisms being the means by which God produces design in the living realm. And he shared these ideas with Darwin in written letters, and Darwin couldn't buy it. And Darwin wrote, in response to Asa Gray's ideas, what a book a devil's chaplain could write on the clumsy, blundering, and horribly cruel works of nature. And so Darwin had real problems with natural evil. So for him, the evolutionary process was a way to explain, the nature red in tooth and claw. And it was a way to make sense of why bad things happen in the world. Why, that life, the world is just a cold, pitiless, indifferent place. And so that to him is how he resolved, the problem of evil, and so you could think of, the theory of evolution as being a theological construct, a type of theodicy, if you will.
Fascinating. All right, last thing, and then we got to wrap this up. I mentioned before that a lot of Christians, I think, have this view of science as an enemy. The science is sometimes presented as a dichotomy. You either believe in science or you believe in Christianity or faith of any kind. How do we break this hold that over the Christians? Any ideas?
Yeah, that's a great question, and I think we need to have a very robust theology for science first and foremost, and part of that is recognizing that God has revealed Himself to us through the record of nature, and that science is the study of nature, and therefore we would expect to see God revealed through nature. I think it also helps to help people understand some of the philosophical commitments that are endemic in science itself, methodological naturalism, that I think makes science, at least in contemporary terms, appear to be atheistic. I think it's important for Christians to understand it was the Christian worldview that was critical in the birth of modern science that arose out of Christian Western Europe, and many of the founders of the disciplines of the different areas of science were devout Christians who were motivated for theological reasons to study nature, where this was natural theology, right? And so I think if we can help people understand the biblical basis for pursuit of science and development of technology, if we can help people understand the historical role that Christianity played in the birth of science and worldview considerations, I think it can help people to make sense or process, what we've learned in science, and and to help people recognize there are alternative ways to think about the data from science that is fully compatible with a creation perspective. I think that helps. That can help a lot. But to me, I always see science ultimately as an act of worship. That when you engage in science, when you contemplate the findings from science, what we're seeing is a characterization of God's revelation. We're studying God's revelation. God's made Himself known to us through the Scripture, through the person of Christ, but also through the record of nature. And so any insight we gain into the record of nature is insight into God Himself, and can be used as a means by which we can elicit worship and praise and appreciation for our Creator. And I think so often those of us that are involved in the science-faith dialogue neglect the real emotional power of what we see in nature to elicit worship. And we get so caught up in apologetics sometimes that I think we fail the church by using the discoveries of science to ignite our imagination and our appreciation of the grandeur of God.
All right. Well, thank you so much to our guest, Dr. Fuz Rana from Reasons to Believe. Head on over to reasons.org and check out all the great content that they have there. We're recommending the book, Thinking About Evolution, I think I have a picture of it over here. Is this the book?
This is the book. Yes,
All right.
indeed.
Thinking about evolution, 25 questions Christians want answered. So if you want to go deeper and have a resource to learn more, check that out. Also, from Reasons to Believe, we're going to have Dr. Hugh Ross on our show on October 14th at 4 p.m. Information will go out in the usual way. And we, thank you for watching. Please like and subscribe and share these videos wherever people are discussing these topics. Please pray for us and for the ministry of Dr. Rana and the folks at Reasons to Believe and all the others who are working in this area to bring, a Christian view of science back to the faith and under the dominion of the kingdom of God. That's part of our dominion mandate, as I see it. We should be doing science. We should be owning science. And as Dr. Rana was just saying, Christians created science, and it only makes sense on a Christian worldview. All right, Jodie, any last words?
Yeah, I have one quick question, and then I'll give a few last words. But just out of curiosity, what is your favorite Hugh Ross book and why?
Gosh, that's a tough question. It's like, what is my favorite flavor of ice cream when I'm in Baskin Robbins, right? I would probably say Creator in the Cosmos is still my favorite book. To me, that was the book that I first read from Hugh that had a huge impact on me as a Christian, helping me to catch a vision for how I could use my training and my experience as a scientist in ministry. And so, and I think that book is really the cornerstone of the ministry of Reasons to Believe in many respects, and it's quintessential Hugh Ross. So that's the book I would probably say is my favorite.
That was indeed a great book, and I want everybody, to subscribe to our channel, Disciples of YHWH. Email us at disciplesofYHWH@gmail.com. Look us up at Facebook, Disciples of YHWH at Facebook. And most of all, pray for us, seek God for us, and please let your friends know about our channel. We're continuing to grow thanks to godly Christians that we invite. And you don't necessarily have to agree with us to be on our show. So if you got any other good, great authors or good personalities for our show, just email us, let us know. We might try to get in touch with them. But God bless our audience, and God bless the United States. And keep our country in our prayers. Keep Afghanistan in your prayers. And God bless y'all.
And all those resources that Jodie mentioned, I'll put in the description box, along with links to these books that we've discussed and so forth. Thank you again for watching. Thank you, Dr. Rana.